And okay, that's better. There we go. Oh, is that better? Right. So we're not doing much today because I haven't managed to print out this activity. And you really need this one printed out. So I've managed to find someone to print mine out because I'm actually in Spain at the moment, unexpectedly. And so I'm going to share the screen so you can see the activity. Shareby Darby. And so the things you need to print, ideally the whole thing out, but actually it would be good if you can print that out, the triangle there, just purely so you can get a feel for that's not essential to be printed out. This one is that you need to cut this out, make 2 copies. It says make 2 copies. Cut each copy into 6 pieces. So I'll be doing this ready for tomorrow morning. And then we'll probably just do something else, maybe play a game tonight, something like that. And then this one, the Pythagorean tree. Look at that, isn't that beautiful? So we've got to cut that out into 24 pieces and then rebuild it and see what fits where. And see if we can look now and see if you can see where things fit. And it's going to give you a really a much stronger feeling for how the squares and the triangles fit together and which triangles fit where. It's going to give you a more intuitive feel, a much stronger sense of shape. So we've got number sense and you've got shape sense, and the two come together. It's about sizes, it's about proportions, it's about how different shapes fit together and make other shapes. And I'm really looking forward to doing this, I have to say. It's amazing when you do activities like this, they seem trivial and they are so not. So there's the Pythagorean tree. And it's interesting because I can't maybe even call that a cactus really, but my grandson looked at it and he said, that's a tree. He doesn't know the word tree. He just looked at the picture and said, that's a tree. And then we've got a little bit of history, which we'll cover. That maybe we'll do that tonight. We'll do the history tonight. I think that'd be quite nice. Yeah, we'll do the history tonight. And then tomorrow morning, now this is what we're going to do for early years. So again, print it out. You can see the only way this is going to fit together, and these all want to be, see where the blue squares are, they're all right angles, and it's important that they're right angles. This is something you could create without having, without cutting it out, but it sure is a lot easier to create if you cut it out. And then so the little activity there for early years, which, well, we might just have a go at that at 10 o'clock. I'll have a go at drawing that out and then see what happens, see if I've managed to see what the difference is between what I draw today and printing that out and cutting it out for tomorrow. So maybe do the same activity twice, do it different ways, we'll see. And then, so all of this, cut it out and just look at that. So you've got, so we're going to again cut this out. We've got an orange square there, but we'll see how the orange square is divided into rectangles. So we'll see what the significance of that is. It's all about gaining that understanding, that feel for shapes. And a lot of people find the Pythagorean theorem, it's like, oh, it's just one of those things. It's like algebra and calculus. It's like, oh, don't want to have to think about it. Quadratic equations, they're just like names that people go, oh. Actually, if you investigate them in these ways, especially if you investigate them before you ever encounter the word Pythagoras, then when you come across the activity in class, when it's been introduced as a formal activity using equations, then when you see it, it's obvious. Of course, a squared plus b squared equals c squared. It's like the square. You can visualize that there's a square on every edge of the triangle, of a right angle triangle, and you've already played and experimented to find out that on the hypotenuse being, let's say, the diagonal one, that if you cut up the other two add them together and literally physically move them around together, they make up this, they have the same area as the big one, as the one on the hypotenuse on the diagonals, which you can see it's the green one there. So the pink and the orange cut up and pasted onto the top of the green one, it's the same area. And that's, if you're investigating that, you know that. It's like you already know that when you get to that point in school where you learn that on just writing out letters. And so it's all makes sense to you. And for those of us that didn't learn it that way in the first place, the first time I saw this, I was like, really? Is that true? And then when they put the formula up, I'm like, I never thought that it actually could be represented by a square on each edge. Never even occurred to me. Then when I saw that, I'm like, ah. So now when I see the formula, I remember it as well because it makes perfect sense. And the only way you really believe it is you cut it all up, place it on and see, yeah, do it in different ways every time it comes up. All different types of shapes and they all come up the same and it's brilliant. So we're going to do that. And what's that age for? That's lower primary. That is if you're aged 5 or 6 to age 8. That's what we're going to do. And it's all about cutting things up and putting them together and just making discoveries. It's just shapes. We're just going to play with shapes. And then we're going to do it again for upper primary, which is age 8 to 11. Again with shapes, we're going to cut them up in different ways and put them together again. And then again with lower secondary, which is ages 11 to 14. Again, we're going to cut up into 5, 6, we're going to cut up these pieces. What does it say? Make a square with 6 pieces and make a square with 5 pieces. So we're going to do that as a challenge. And then year 9. So year 9 and 10, 11, 12 is about 14, 15-ish, 13 to 15, depending where you are in your educational journey. And that's, this is the same thing, but with hexagons. But look at that hexagon, 1, 2, 3, 4, 5, 6. That's not a regular hexagon. That's a wonky hexagon. But you know what? It's got A to C as one edge, C to I is one edge, I to H is one edge, H to G is one edge, G to F is one edge, F to A is one edge. So 1, 2, 3, 4, 5, 6. It's a hexagon. It's just not a regular hexagon. And then we've got these other 2. We've got a triangle at the other end. So there's 2. Yes, they are. They are congruent triangles. So EJD is congruent to ABC. It's just rotated. It's a rotational. Also, it's the same triangle, only rotated. And so you might need that. I don't know. We're going to find out. We're going to play with it. I love it. This is brilliant. This is going to be so much fun. I've never seen this. I have never seen this, and I'm really looking forward to seeing it. So there's 2 of those to cut out, looks like. And then upper secondary, so we're talking 16 to 18-year-olds, maybe 15 to 18-year-olds, depending where you are in your educational journey. It's not a competition, it's just you are where you are. And that is super important to know, that these activities are low threshold, high ceiling. So you start where you're, in fact, start at the bottom. I would start with the early years activity. I am going to start with the early years activity, not only because I'm doing these lives, but because it's all building up, especially if you've already encountered Pythagoras' theorem and you're like, ugh, please do start with the early years activity and just build it up, and then do the one with the hexagons. I'm so looking forward to that. I know I'm going to get some deep insights into how this all works by doing it that way, by following in the footsteps of Leonardo da Vinci. Wow, how cool is that? If you don't know who Leonardo da Vinci is, Google him and have a look, see. He was the first one who invented, oh dear, what's the name of it? When a human has like these wings and they fly off a cliff and they just, it's like a glider. What's that thing called? Somebody tell me what that thing's called. And yeah, and that's it. that's what we're doing. So I'll stop the share. So please do, as you can see, printing that out is super important. And that's a whole family activity. You can all play together, print out, make one for the younger learners and have them play in their own way. So let them do the activity for the younger early years activity, but then let them have a play with all the different activities, print out enough for everyone, each person, and then just keep building up. And where the younger learners kind of go, well, that's not really relevant to them, just let them play with the shapes. So that they just have a go at the shapes and see which ones fit together and discover other shapes. What other shapes can they make with squares and triangles, and just have a play with it. And so, yeah, that's what we're doing tomorrow morning in the end, because I will have my printouts and I'm going to be able to cut them all up. I have everything ready to go for 9 o'clock London time tomorrow morning, and I'm really looking forward to it. I have to say, it's going to be a long session because I'm going to have a play too. Yay, looking forward to it. So I'll see you, well, I'll see you at 10 London time for an early years. We'll just do a quick early years activity. What I'm going to do is I am going to attempt to do at least an approximation to the activity, and then see how the printout is different to me doing my best to draw one, see what the differences are, the distinctions. I will see you later. Thank you for joining, and have a wonderful day, morning, evening, night. Thank you.